Typing is something that may be actually weird for most Python programmers. When you hear about Python, you know that it is a friendly language. You don't have to care about the type you are passing to some function or returning. In C++, Java, and other languages, you have to specify that your function will take string and integer as an argument, and it will return, for instance, a string. If that doesn't work during compilation time, you get an error. In Python, there is no way of indicating that and no way of detecting, or at least there was no way until typing was introduced. It's great, but it's still not used by everyone, so I hope that after watching this video, you will be able to introduce it into your project. Let's think about why would you like to use typing. We have some class employee, and that class expects some name and salary. We have no idea what types of those data will be, but I can guess that salary is some value, some integer or a float, more likely a float. Name is probably a string. So if I start coding and I use that variable and place a dot here, there is literally no autocompletion. I would like to have some because I don't want to remember about all methods that are available for string class. I would like to be able to work like with variables that I initialized in place, like here. This is my test, and on a variable we see methods available for strings because my IDE, which is in that case PyCharm, in your case it may be Sublime or VS Code, the IDE figured it out. That's probably a string, so maybe we can make it uppercase for an instance. That's great, but it doesn't work for us. And even if I pass a string here into my employee class, it still doesn't give me that autocompletion. And what is more, I can make a mistake and pass a 10 instead of Smith. He's 10 on 10, but that still doesn't make me happy because the code doesn't work now. And if I had some way of detecting that, even if it didn't change execution of the code, maybe I would notice it earlier. And that is where typing comes. Typing means that, at least in Python, you can specify a hint for your editor that says this is gonna be a specific type. We can add type hints to our arguments. We can add them to return values, but also to the variables definitions. So we're gonna start with that initializer and we're gonna modify arguments. All you have to do is to place those little two dots of a colon and a type. We're gonna have a string for name and a float for salary. So now if I access name, whoa, it knows that this is a string. And what's more, initialization of that 10 employee says that there is something wrong. We see that expected type string got integer instead, but still I can run my software and there is gonna be no error. We can start printing names instead of the value we had before, and you see name is 10. And that is fine because you probably started using Python because it's a friendly language and it allows you to do different things. And Guido van Rossum said that Python is never going to be strictly typed and it's not gonna be a convention everyone has to follow. But at the same time, you can already start benefiting from typing, even if you just add some typing to method arguments. So let's fix the issue we have here. Let's change that to Smith again. And what else can we do? We already fixed arguments, but we could also tell our code what values we are expecting from functions or methods. Like this get salary summary doesn't specify much. I mean, it is returning a string and my IDE is smart enough to figure it out, but I could tell it using such arrow that I'm gonna return an integer. And not only it treats it as integer, but it also detects a wrong return type. And if I want to fix it, I have to change it to a number. And that is really great because right now if I have the string here, I have lower chance of making a mistake. So if I was writing some functionality, maybe get tax based off salary, I can specify float as return value. I can start calculating the tax, which in that case is gonna be just salary multiplied by the tax value, which is a global variable here. And I have an information that we expected to return a float, but we have no return value. That's great. We found a bug. So we can fix it, return tax, and we're good. It has some imperfections, and I can demonstrate it on another case of typing. We're gonna put a type hint for employees list. If I want to specify it when I'm declaring some values, I can just put that type hint before assigning the value. So I'm gonna say it is a list of employees. And you may want to use values like Dict or like list the typical way you do, which is lowercase, but I prefer to use uppercase. Uppercase is an alias that comes from typing module, and it will work exactly like the lowercase one, but in some cases it may save you from having errors. I was testing it before, also testing it with Union that I will explain later, and I had no errors. On the other hand, I work with backends and multiple applications on a daily basis, and I had multiple issues when I was using database libraries like SQL Alchemy. In those cases, using lowercase types was causing errors. So I always tell others to use the uppercase because it works, but has a lower chance of causing an error in case of using some external modules. So we have that case here, and if I was about to append some value, maybe an incorrect one, like just 10, then yes, I would have an information that expected type employee doesn't match that integer. But if I was initializing it here in place, there still is a chance that it will not be detected. So the system isn't flawless, but I still believe it is good enough to be worth using. Also, my IDE is smart enough to figure out that this is a list of employees. So if I type employee and put a dot, it knows there are employees only. And I had no typing. But if I was initializing those values during runtime, not inline like here, it would have no idea about it. Also, if I have some example value of another type, it is going to be confused now. Now I see methods for both employees and strings. And if I try executing that, maybe employee upper, I will get an error. So I still prefer to have that typing here. And now I see that upper is some unresolved attribute reference, which just means that employee class doesn't have such method implemented. And if I wanted it to do some toUpper functionality, I would have to implement it myself. And in that case, the error disappears. So the list is actually the first complex type we talked about right now. We talked about some string and some float type hint, and a list is already more advanced. You noticed that I imported it from typing module. We can also do typing for dictionaries, and there are actually two kinds of type hints for dictionaries. Let's start with the simple one. I will make some very basic sum dict, and let's make a type hint that tells us that this is a dict made of string and some list of integers. So in our case, string is gonna be the key and list int is gonna be the value. We also have to import that dict from typing, and we can start creating our dictionary. It is fine to start initializing it here, but if you like to store that type hint somewhere else, you can just do it in 2 different lines, and that is also fine. So let's start initializing our dictionary, and we will run into the similar issue like here with the employees, and I will also remove that example line so everything here is correct. Let's create a dict, and our first key is just gonna be first. I'm not going to go too creative with that, and that will be a list of integers. A single integer, but it is a list. Second argument is gonna be a string value, and as you can see, that is incorrect, but you can do that. And there will be no crash during runtime because Python is not strict about typing. The thing is that even if I try accessing that second value right now, we still see only list and generic object methods available. So as long as you don't make a mistake of initializing everything inline, in place, by manual assignment when the variable is created, you're gonna be fine, because probably if you are trying to add a new key, you won't be able to add something incorrect because it knows that it expects something else. So it's not that bad. If we want, you can go a bit more strict. And also, that will be very handy because you can imagine that dictionary of such kind, like such typing here, is hard to develop. At some point, you may start making hints that say that we have a string and inside of it there's another dictionary, and that dictionary is having a string and another dictionary, or maybe just a list. And that's too complex. I wouldn't like to try editing that. So instead, we can import another class, which is a TypedDict, and we can declare our dictionary as a class. So that's going to be class, maybe book, and it is a TypedDict, and it has 2 attributes. First one is a name, that is a string, and another author, it's also a string. Then we can create a dictionary that is made based on that schema, and we will call it my book. That is type of book, and we have some author name or maybe book name. Let's be a little narcissistic. Let's call it best book ever. And author, it's obviously us. So me, of course. And that works. We can even print our book. And after printing, we may see, oh, I printed the wrong name. That's my bad, that's on me. We printed it and we see we have some dictionary. We can try assigning a wrong type again, like 2, and we see information that we are wrong, but like in previous cases, we are not really raising any exceptions if anything is wrong. So we can add a year parameter, that's fine, and we can run it. In our IDE, we see that something is wrong, but the code still works, doesn't crash at all. I think using TypedDicts is very useful, but there are cases when we want to have them as separate classes, because maybe that dictionary will contain value that was read from some configuration file, and now it is gonna be used by whole application. In some cases though, we just create a local dictionary in some function, and we don't even return that dictionary. We use it for our operations, and we return something else. In that case, we may want to create that locally and to not have it available for importing from other files. So in that case, there is another syntax for it. I just commented out the book, so reference is no longer available. So let's declare our book type in the line 41 just above initializing the dictionary. We're going to create book just like a variable, and that equals to TypedDict. And as a first argument, I'm going to pass just a name of that class, and then after comma, there goes some kind of dictionary with a hint. So name, that's a key of type string, and author, and that is also string. And please notice that so far we were passing those types after names of variables, but we weren't treating them as strings. In that case here, this is actually a string, and that's why those are in commas. I also made a typo here, so let's put an H, and I have some highlight telling me that a variable in a function should be lowercase. That is correct, but on the other hand, I am using that book variable as kind of a class, so I would like to have it uppercase. We make classes uppercase, right? And also, we have no issues here because parameters are correct and the year is highlighted for the same reason it was highlighted before, because it's a wrong key. And still, during execution, no exceptions are raised. We're almost done with this tutorial, but I would like to also talk about union, about any, and about how typing can help you writing well-documented code. There are cases when we don't want to limit ourselves with passing a single type. There are so many sorting methods that can work with different kinds of lists, arrays, and so on. And if we were limiting them to just work with a list, that would be just annoying for programmers, or maybe inefficient if you started writing too many different methods to handle all of those cases. Sometimes we want to be able to, for instance, pass a list of integers or a single integer, pass list of strings or integer. And in that case, we can use union. So let me create a variable union example. And we have to import union, of course, from the typing module. That's imported. And we declare union, we use the square brackets, and the first type we are gonna support is list of strings. Second one is gonna be an integer. And now we can try passing a string. That's incorrect. But if we enclose it, that is going to work. When we start checking what is available for our variable, we see that we can access both list operations and integer operations. If we try maybe pop, that is a method that will remove the last value from our list and return it. So when we place another dot, we expect to have a string returned. And that's smart enough to see that this is actually a string. So I think it's very useful. I'm not going to go on with that example, but we may also have cases when we expect literally anything. Maybe we have some logging mechanism or some print. And we don't need a complex example here. We can just make a print anything function and that's gonna expect any value. That also has to be imported. And now we don't really have any hints for the data. We can print it, and we can pass anything to our function. And that's gonna work. So why? Why do we do that? Is there any benefit? Because I could have just skipped that. There actually is benefit. One thing is that type hint is generally supported by modules that generate documentation. And it's very easy to notice if typing is off. You basically get highlights telling you that you made something wrong. On the other hand, updating documentation is quite time consuming. And in many cases, you don't have to write any documentation if a function or method is simple enough to figure out stuff from reading the code or reading the name. But you need to know the types that functions return or expect, and that's why you may want to generate a simple documentation even if there is no string that describes what the function does. If you use type hints, you don't really have to do that. And also, if you just hover over any function or method, you see what types it expects. Like here, my book, and this is the schema. That's actually applied schema, but here we have schema of the class we have. And also, there are both methods like dir and help that can guide us when debugging or executing the code. And if you are not able to access some documentation, you can always try printing it in the code. So we can print help function and pass that print anything to it. Just remember to not add any brackets here that would call that function. We can run our code and we see that there is a print anything that returns some any. We can do the same with employee, and we have whole documentation of our employee, and we know that the constructor expects name, that is a string, and salary, that is a float, that there are some methods, and that get salary summary returns a string, and get tax returns a float, and that can be super useful, trust me. And that's basically it. Using typing can help you detect errors early. It can save you time on writing documentation, but it doesn't make your code faster. Remember, if you see anyone telling you that it's gonna make your code faster, that is a myth. In fact, typing is ignored by the interpreter, so it shouldn't modify the way your code runs, at least unless you are using some external module that was made to enforce static typing. Anyway, that's it. I'm proud of you because it was really tough to listen for 20 or even more minutes. So, if you are still here, I will be glad if you subscribe and give me your feedback in the comments. And what else can I say? See you in the next video.